Welcome, this is Evan Smith, College of Technology, Idaho State University. Wanted to take a minute and talk about the thermal expansion of materials. When a material or object heats up, it's going to there's going to be all those molecules that are inside pushing against it as the temperature gets going. If you think about that as a structure, so it's going to actually grow in length a little bit. And the formula that they've come up with that works, they've calculated the coefficient of thermal expansion for the material, and you're going to find out that the change in length or diameter, if we're talking, essentially across what we're looking at, it's going to grow that much. Change in length is going to be equal to the coefficient of thermal expansion, which they've studied and experimented and come up for each material, times the change in temperature times the length of the object that we're looking at. And so here's a list of the coefficients that are there. Let's look at an example. So if we have a steel bar, so we're going to be looking at steel, and it's a 60-inch long bar, and we're going to be going from 70 degrees Fahrenheit at room temperature up to 230 degrees Fahrenheit, which means we've got a change in temperature of 160 degrees Fahrenheit. And recognize that the units are specific to the change in temperature, so it does need to be different because 1 degree Fahrenheit is less than 1 degree centigrade when it changes. So if we want to look at this problem, our change in length is going to be, equal to the coefficient of thermal expansion. We're looking at steel. That's going to give us 6.1 times 10 to the minus 6th inch per inch degree Fahrenheit. They don't put the units up here, but that's the units they keep, so the inch per inch cancels out, and they come up with that. In part, I don't know if I can explain it very well. They put it in, essentially, if you think of it as a volume, it's going to be growing both directions, but anyway, that's the units they use. So we're going to be growing 6.1 times 10 to the minus 6 inch per inch, and we're going to be raising that by 160 degrees Fahrenheit, and as it does that, we've also got a length of 60 inches. And when we look at units, we're going to see that inch per inch is going to cancel out, Fahrenheit is going to cancel out, we're left with inches. And so when we run that calculation through, we're going to see that that is going to be equal to, and hopefully my calculations are correct, that should be 586 inches. In other words, 58.6 thousandths of an inch is what that steel bar is going to grow. 60 inches is a pretty good distance, and so it's going to grow a little bit there. And let's look at another problem. Here we've got a steel shaft, and the steel shaft is 2 inches in diameter, and if you remember, steel is going to be 6.1 times 10 to the minus 6th for the coefficient of thermal expansion. Take a second or better take a minute. Take a minute or two just to see if you can solve the change in diameter of this particular steel bar. And again, you can look at the diameter as the length. In this case, it's going to be growing the same. If you ran your calculations, you saw that we should have grown about 1.6 thousandths of an inch. So just by heating that 130 degrees, the 2-inch shaft is going to grow by that amount. Not a lot if you're trying to do a shrink fit on a shaft to a hub, but so you might need to be thinking about either icing the shaft, get a little more temperature change in that. So if you wanted to look at a brass rod, it's got a different coefficient of expansion, a 1-inch brass rod, and you heat it to 130 degrees, it's going to make a difference of 1.5 thousandths just by the length it's going to see. Did the same thing to steel, it's only going to grow 10 thousandths of an inch. Just out of interest and curiosity, if you wanted to look at a steel railroad track, 1/4 mile long, 1,320 feet long, say we have an Idaho night of 50 degrees Fahrenheit, And we're going to get hot in the day, 100 degrees Fahrenheit, and maybe it's really only 80, but the steel is going to be having the sunshine on it with the radiant heat load and all that good stuff. We're going to see a change in temperature of 50 degrees Fahrenheit. Run the calculations, and I've already crossed out the units for you. You'll see that we're going to grow 0.4026 feet. Kind of a nifty calculation to go down to the 10,000. If you wanted to put that, well, feet, wait a minute, we've been talking inches, but we'd look at feet in this case. Think of the inch per inch. That's where the beauty of this coefficient comes in, is it's really, you can look at the change in length according to the units you're working on. So we can convert that 0.4026 feet into 4.8 inches should you like to talk inches. And if you have any questions, we can discuss those later.